Good morning, students. This is Sheba. Now we are going to discuss about the electronic devices UNIT-1 semiconductor diode. In our previous sessions, we have discussed about intro to electronic devices, semiconductors, and last session we have discussed about PN junction diode. In that class, we have discussed about what is meant by PN junction and what are all the real-time applications of this PN junction. What is the depletion width created in PN junction and how is the dopant distribution in a PN junction diode occurs. Now, moving to the next part of it, PN junction diode characteristics. Yes, what is meant by this characteristics? As I have mentioned in the earlier class, this diode acts in two basic characteristics. First one is the forward biased condition and second one is the reverse biased condition. What is this forward bias and reverse bias means? A forward bias diminishes the potential barrier which allows the current to flow effortlessly across the junction. Whereas in reverse bias, it reinforces the potential barrier and impedes the flow of charge carriers, that is, restrict the current flow. In simple, forward bias means putting a voltage across the diode that allows current to flow easily, while reverse biasing means putting a voltage across the diode in an opposite direction. The voltage reverse biasing here doesn't cause any appreciable current to flow. In forward bias, the voltage potential is connected positive for the p-type material and negative to the n-type material across the diode, which has the effect of decreasing the PN junction diode's width. Whereas in reverse bias condition, positive is connected to the n-type and negative is connected to the p-type, which increases the depletion layer width and which restricts the current flow. Okay, before getting into the topic of discussion, let us have a brief discussion about the real-time application of forward bias or reverse bias. For example, LED. LED means a light emitting diode. Hope this now you are very familiar with this LED since we are discussing it from the intro class. This LED emits light when it is forward biased and it emits no light when it is reverse biased. That is, the intensity of light is proportional to the square of current flowing through the device. Yes. And so, whenever if this LED is blinking, it is forward biased, and it stops blinking means it is said to be in reverse bias condition. So, moving to the characteristics, here it is given by the diagrammatic representation how forward bias takes place. As I have mentioned, positive side is connected to the p-type and negative side is connected to the n-type. It causes narrow depletion region which is marked clearly in the diagram, and it creates the current to flow freely through the circuit. Moving to the calculation part, this is the forward bias characteristics, that is linear current flow is there. If you are drawing across the current to voltage, normally voltage is taken in the x-axis and current is taken in the y-axis. Unit of voltage is volt and current is milliamps. And this is the diagrammatic representation of forward bias and reverse bias corresponding to the silicon and germanium. Two materials of semiconductors are taken First one is the silicon Si and second one is the germanium Ge. You can see clearly the linear characteristics of increased current flow occurs here, and depletion width is very narrow, which is given by the equation. W is equal to 2 epsilon naught epsilon r into V naught minus Vf divided by Q into Na plus Nd divided by Na into Nd, the whole power 1 by 2. In common, it is depicted as V, whereas now for forward bias we are taking as V naught minus Vf. Moving to the reverse bias, you can clearly see in this diagram, this reverse bias, negative is connected to the P side and positive is connected to the N side. Since you are crossly giving the connection, the width of the depletion layer gets increased due to the removing of holes and electrons from the corresponding region. So, width of the depletion layer is increased, which blocks the current flow, and thus it works in the reverse bias condition. And this is the reverse bias characteristics of PN junction diode. You can see clearly in this diagram there is no positive current flow at all. It starts to create breakdown voltage. You can clearly see in negative sides it conducts and it creates a breakdown voltage there. VR and IR represent the reverse bias voltage and reverse bias current. Vf and If corresponds to the positive voltage, forward biased voltage and forward biased current. So this is the reverse saturation current which occurs here and breakdown voltage created at the reverse bias condition. Corresponding depletion layer with the same formula, a small change V0 minus Vf is given there. Here negative voltage is created, minus Vr, minus into minus, the equation becomes V0 plus Vr, 2 epsilon naught epsilon r into V0 plus Vr divided by Q into Na plus Nt divided by Na Nd, the whole power 1 by 2. This is the reverse bias characteristics, and corresponding to the total characteristics. Hope now you are very familiar with the forward bias and reverse bias characteristics. Drawing it as a whole in a single diagram, you are taking plus V plus I minus V minus I. Positive side correspond to the forward condition, forward bias condition, and negative side correspond to the reverse bias condition. Forward conduction and forward junction potential is marked, whereas in reverse bias condition, reverse breakdown voltage and reverse breakdown is marked. And this is the PN junction diode current voltage characteristics. This is not only for theoretical purpose, corresponding to the laboratory purpose also. You will be finding the values in real time. You will be connecting the diode in a circuit. You will be measuring the voltage created across the junction when it is forward biased. Similarly, you will be measuring the values of voltage and current when it is created given in the reverse bias condition, how it blocks the current, how it resists the current, and how the breakdown voltage occurs there. This is the functional characteristics of PN junction diode. As I have mentioned earlier, in the real-time application of LED light emitting diode, it is forward biased when it is in the working condition, and it is reverse biased when it is in the off condition. The free electrons in the conduction band recombines with the holes in the valence band and releases energy in the form of light, corresponding to the light emitting diode forward bias condition working. In normal PN junction diodes, silicon and germanium are mostly used. If you correspond to the most widely used on these two material, silicon is the most widely preferred, corresponding to both the material because of the less sensitivity to the temperature. Yes, why silicon is mostly preferred? You must know the reason. When you are going on real-time implementation, you need to withstand the heat and temperature of the surroundings. Silicon withstand more temperature. It is less sensitive to the temperature changes, and so it is most widely used in all the real-time applications. And this is about the PN junction diode characteristics and its real-time application. Hope now you are very clear about the concept of PN junction diode, its parameters and its characteristics. If you have any doubts about this PN junction diode and its characteristics, you can ask me and get the details. Thank you.